All right, graphs of inverse functions. We said this earlier, we're going to say it again. The graph of y, given the graph of y is equal to f of x, we can sketch the graph of f inverse of x by reflecting by reflecting the graph of y is equal to f of x in the line y is equal to x. So this is demonstrated in the diagram top right. We have the graph of y is equal to f of x, which looks like a logarithm graph. And you have the graph of y is equal to f inverse of x. All right. And yeah, so, and notice that the graph of a function and its inverse are mirror image of each other in the line y is equal to minus x. In other words, if I reflect the graph of y is equal to f of x in the line y is equal to x, the resulting graph, the image of y is equal to f of x is f inverse of x. And the reason for that is whenever you reflect a point in the line x is equal to y, what you do is the image point will be, you'd have to interchange the x and y coordinates to get the image point. So in other words, for example, the point, let us say 3 minus 2, 3 minus 2, that point reflected in the line y is equal to x becomes the point minus 2, 3. In other words, the x and the y coordinates interchange. Now, this happens whenever you find the inverse of a function. Therefore, if you reflect a graph in the line y is equal to x, the resulting graph is the inverse of the original graph. Example 21 asks us to sketch the graph of y is equal to 2x plus 1 and hence sketch y is equal to, sketch the graph of f inverse of x. All right, so let's sketch the graph of f of x is equal to 2x plus 1. First of all, let's say y is equal to 2x plus 1. Now, y is equal to 2x plus 1 is a linear function. The graph of a linear function is a straight line, and only 2 points are needed to draw a straight line graph. So to get 2 points, I'm going to start by selecting a value of x. So let us say when x is equal to, let us say, minus 2, y would be equal to 2 times minus 2 plus 1. This is, sorry, 2 times minus 2, not minus 3. 2 times minus 2 plus 1. This is minus 4 plus 1, which is minus 3. So 1 point on this graph is minus 2, minus 3. Remember, I need 2 points to draw a straight line graph. So I might say, what happens when x is equal to positive 2? Y would be equal to 2 times 2 plus 1, which is 5. So another point on this line is the point what? 2, 5. All right, so I have 2 points on y is equal to f of x. I'm going to plot them. Minus 2 minus 3 is this point. And 2, 5 is this point. So I just line them up with my ruler and draw a straight line through them. Right. Line them up with my ruler, draw a straight line through them. This is the graph of f of x is equal to 2x plus 1. All right, next I'm going to draw the graph of f inverse of x. And I'm also going to draw the graph of y is equal to x. Technically, well, in other words, what I'm saying is that you can do the reflection without drawing the line y is equal to x. And I can tell you why. Because you know what happens to a point when it is reflected in the line y is equal to x. So f of x, which is equal to x minus 1 over 2. You didn't need that. But just remember that if I reflect the point minus 2, minus 3, sorry, let me just make it official a little. So I have points on f of x, and I want points on f inverse of x. So the point minus 2, minus 3 on f of x is going to become the point minus 3, minus 2 on f inverse of x. The x and the y coordinates are going to interchange. I only need 2 points or a straight line graph. Now the next point, 2, 5 on f of x is going to become the point 5, 2 on f inverse of x. All right, let me change some colors. I'm just going to draw the line y is equal to x. I'm sure I've said this before, but if I haven't, I'll say it again. Y is equal to x is a straight line that passes through all points on the graph where x and y have the same value. The line y is equal to x is a straight line that passes through all points on the graph where x and y have the same value. So the line y is equal to x is going to pass through the points 1, 1, 2, 2, 3, 3, 4, 4. It's going to pass through the origin, which is 0, 0. It's going to pass through minus 1, minus 1, minus 1, minus 2, minus 2. The line y is equal to x is a straight line that passes through all points on the graph where x and y have the same value. So this is y is equal to x. Next, I'm going to draw the graph of I'm going to draw the graph of f inverse of x. We already worked out points on f inverse of x. Minus 3, minus 2 is a point, so this is a point. It is the reflection of the point minus 3, minus 2, minus 2, minus 3. And the next point is 5, 2, which is this point here. And then let's just draw a line. Want to ensure we line it up properly. Not working for me right now. Let's go again. Sometimes this thing gives trouble, like what it's doing to me now. Good. All right, this would be the line, the graph of y is equal to f inverse of x. which is y is equal to x minus 1 over 2. So again, in order for you to draw the graph of f inverse of x from the graph of y is equal to f of x, all you have to do is to reflect the graph of y is equal to f of x in the line y is equal to x, and the resulting graph will be f inverse. The graph of y is equal to f inverse of x. How do I go about doing that? I would obtain points or coordinates of points on the line y is equal to x, interchange the x and y value so that I would get what points on the graph of y is equal to the inverse of x, and then use those points to draw the graph of y is equal to the inverse of x.